Welcome to Sahara IAS. In the last session, we have gone through some laws of exponents. So, using those laws in this class, we will be doing some problems. Let's consider the first problem like 7 to the power of 1.5 into 7 to the power of 4 by 7 into 7 to the power of 5 by 2 is equal to 7 to the power of x. Let's find the value of x. What is the value of x? As we have discussed in the last class, whenever there is multiplication and the bases are same, here also base is 7, here also base is 7 and here also base is 7. So, we can simply add the powers. So, here it will be 7 to the power of 1.5 plus 4 by 7 plus 5 by 2. Now, I can write 1.5 as 3 by 2. So, it is 7 to the power of 3 by 2 plus 4 by 7 plus 5 by 2. If I add 3 by 2 and 5 by 2, it will become 8 by 2, which is nothing but 4. So, 7 to the power of 4 plus 4 by 7 is equal to 7 to the power of x. Now, as we see here, the base are same. So, I can directly equate the powers and I can write it as 4 plus 4 by 7 value is equal to x. So, if I take the LCM as 7 here, 7 4s are 28, 28 plus 4 32. So, 32 by 7 will be the value of x. So, we have used two laws of indices here. So, first one is when the base are same, we can directly add the powers. This is the first rule which we have used, and the second rule that we have used is whenever the bases are same, we can equate the powers. Hope the first question is clear. Second question, let's say a divided by b to the power of x minus 7 is equal to b divided by a to the power of x minus 13. Then we need to find what is the value of x. What is the value of x? So, what can be done here? Here, as we see, the base are not same. Here the base is a by b, here the base is b by a. So, I can't directly equate the power. So, let me try to make the base same. How to make the base same? As we have studied, a by b to the power of m minus n can be written as b by a to the power of n minus m. This we have seen in the last class. Using that, I can write this question as a by b to the power of x minus 7 is equal to, if I take b by a as a by b, then I need to change the power as x minus 13 to 13 minus x. Now, the base are same, I can equate the powers. So, it will become a by b is a base here, a by b is a base here. So, I will be equating the powers directly and I will get x minus 7 is equal to 13 minus x. If I take x to this side and send 7 to this side, I will get x plus x is equal to 13 plus 7, which simply means 2x is equal to 20. So, x value here is 10. So, again here we have used two laws. One, if I take a by b to the power of m minus n, if I interchange the base, then I will get b by a is equal to n minus m. This is first rule. And second rule, as usual, we have used it as when the bases are same, we are equating the powers. Next question. Let's take this question. Yes. Suppose if we have 3 to the power of, let's take 3 to the power of a is equal to 243. We can take 243, yes. Then find 5 to the power of a minus 3. If we observe, 3 to the power of 1 is 3, 3 to the power of 2 is 3 into 3, which is 9. Then 3 to the power of 3 is 3 into 3 into 3, which is 27. 3 to the power of 4 is 3 into 3 into 3 into 3, which is 81. Similarly, 3 to the power of 5 will be 3 into 3 into 3 into 3 into 3, 5 times, which is equal to 243. So now we understood that 3 to the power of 5 value is 243. So I can write this as 3 to the power of a is equal to 3 to the power of 5. Again the base are same. I can equate the powers as a is equal to 5. Now the question is asking for 5 to the power of a minus 3. Now we got the value of a. We will be substituting that here. We will get 5 to the power of 5 minus 3, which is 5 to the power of 2, and 5 to the power of 2 value is 25. So answer for this question is 25. Coming to the next question. Suppose if we have one more similar question, 3 to the power of x minus y is equal to 27 and 3 to the power of x plus y is equal to 243, and I want the value of x. Find x. Here what can be done? Again express 27 in terms of 3 to the power of something and 243 in terms of 3 to the power of something. I will get 3 to the power of x minus y is equal to 3 to the power of 3. As we saw, 27 is nothing but 3 cube, and x to the power 3 to the power of x plus y is equal to 3 to the power of 5, as 243 is equal to 3 to the power of 5. Now bases are same. If I equate the powers, here I will get x minus y is equal to 3, and here I will get x plus y is equal to 5. Now this is simultaneous equation wherein I have two equations with two unknowns x and y. Now I will be adding these two equations. X plus x I will get 2x, and minus y and y I can simply cancel, is equal to 3 plus 5 is 8. So value for x will be 4. If at all the question is asking for value of y, I can simply substitute this x value in this equation, that is 4 minus y is equal to 3. So y value will be equal to 4 minus 3, which is equal to 1. Then I will give you some standard powers. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128, 2 to the power of 8 is 256, 2 to the power of 9 is 512, 2 to the power of 10 is 1024, and so on. Similarly, 3 to the power of 1, we have already seen this, 3. 3 to the power of 2 will be equal to 9. 3 to the power of 3 will be 27. 3 to the power of 4 will be 81. 3 to the power of 5 will be 243. If we consider 4, 4 to the power of 1 is 4. 4 to the power of 2 is 16. 4 to the power of 3 is 64. 4 to the power of 4 is 4 to the power of 4. As we know that, we can also write this as 4 to the power of 2 whole to the power of 2. And as 4 to the power of 2 is what? 16. So 16 square will be the answer for 4 to the power of 4, which is 256. We can continue like this. And when we consider 5 power, 5 to the power of 1 is 5. 5 to the power of 2 is 25. 5 to the power of 3 is 125. 5 to the power of 4 is 625. As we know that 5 to the power of 4 can be written as 5 to the power of 2 whole to the power of 2. 5 to the power of 2 is 25 whole square, and 25 whole square value is 625. Then 5 to the power of 5 will be 3125, and so on. So these standard values you should be knowing, at least the values that I have written on the board, this you should be knowing. Coming to the next question. Okay, let me consider this. 256 to the power of 0.16 into 256 to the power of 0.09 is equal to question mark. So this is what the question is. Now I can write 256 to the power of 0.16, as the base are same and we are multiplying the numbers, we will be simply adding the powers. So answer will be 256 to the power of 0.16 plus 0.09. This can be written as 256 to the power of 0.25. But as we know that 0.25 can be written in the fractional form as 1 by 4. This can also be written as 256 to the power of 1 by 4. And if we observe in the powers of 4, 4 to the power of 4 is 256. So we can also write this as 4 to the power of 4 whole to the power of 1 by 4. And as we saw in the previous previous class, a to the power of m whole to the power of n can be written as a to the power of m into n. Applying that here, 4 to the power of 4 into 1 by 4, I can cancel 4 and 4. So answer is 4 to the power of 1, which is 4. So answer for this question will be 4. Considering the next question. Okay, if the question is like this, (25) to the power of 7.5 into 5 to the power of 2.5 divided by 125 to the power of 1.5 is equal to 5 to the power of question mark. I need to find the what will come in place of question mark. So 25 can be written as 5 square whole to the power of 7.5 into 5 to the power of 2.5 divided by 125 can be written as 5 cube. So it is 5 to the power of 3 whole to the power of 1.5 is equal to 5 to the power of question mark. Now this is 5 to the power of, here I can take this a to the power of m whole to the power of n is equal to a to the power of m into n. I can use this and I can write this as a to the power of 2 into 7.5 into 5 to the power of 2.5 divided by 5 to the power of 1.5 into 3 will be 4.5. So this can be written as, this is equal to 5 to the power of question mark. I am keeping the RHS as it is. Then this is 5 to the power of 15 into 5 to the power of 2.5 divided by 5 to the power of 4.5. Now as the bases are same, I can add and subtract the powers. So whenever there is division, we will be subtracting the powers, and whenever there is multiplication, we will be adding the powers. So it will be 5 to the power of 15 plus 2.5 minus 4.5 is equal to 5 to the power of question mark. Now as the base are same, we can equate the powers. So I will write it here, 15 plus 2.5 minus 4.5 is equal to question mark. Then if I take this here, 15 minus 2 will be question mark. 15 minus 2 is 13. So in place of question mark, I should have 13. So answer for this question will be 13. Next question. Suppose if we have the question like 0.04 to the power of, let's say 0.04 to the power of minus 1.5 is equal to question mark. Now as we know that 4 can be written as 4 by 1, 0.4 can be written as 4 by 10, 0.04 can be written as 4 by 100, then similarly 0.004 can be written as 4 by 1000 and so on. So here we are having 0.04, so we can replace this by 4 divided by 100 whole to the power of minus 1.5. Now 4 by 100 if I take, if I cancel this, I will get 25. So it is 1 by 25 whole to the power of minus 1.5. Now if I consider this as the power is minus, if I take the reciprocal, I can make it as plus. So 25 to the power of plus 1.5. As I am taking the denominator to the numerator, I am changing the sign of the power. Now 1.5 can be written as 3 by 2. So it can be written as 25 to the power of 3 by 2. As we know that 25 is 5 square, I can also write this as 5 to the power of 2 whole to the power of 3 by 2. Now 5 to the power of 2 into 3 by 2, as we know that a to the power of m whole to the power of n is a to the power of m into n. Now I can cancel this 2 and 2. So 5 to the power of 3, 5 to the power of 3 is 125. So answer for this question is 125. Next question. Let's consider this question. it is given that 1 divided by 1 plus a to the power of m minus n plus 1 divided by 1 plus a to the power of m minus n is equal to question mark. The question looks a bit difficult, but it is very easy. For example, as we see, a to the power of m minus n or a to the power of x minus y can be written as a to the power of x divided by a to the power of y. I will apply this formula here. I can write this as 1 divided by 1 plus a to the power of n divided by a to the power of n plus 1 divided by 1 plus a to the power of m divided by a to the power of n. Now if I take the LCM here, I will get this as 1 divided by a to the power of m plus a to the power of n whole divided by a to the power of m plus 1 divided by a to the power of n plus a to the power of m whole divided by a to the power of n. Now as we know that 1 divided by x by y can be written as y by x, I will simply take this a to the power of m and a to the power of n to the numerators, and this can be written as a to the power of m divided by a to the power of m plus a to the power of n plus 1 a to the power of n divided by a to the power of m plus a to the power of n, as a to the power of n plus a to the power of m can be written as a to the power of m plus a to the power of n. As a plus b is nothing but b plus a, we can interchange this. Now this, as the denominators are same, I can say it as a to the power of m plus a to the power of n divided by a to the power of m plus a to the power of n, and I can cancel it out, and the final answer for this question is 1. So this is how, using the law of exponents, we will be solving some simple questions. This is all for this class. Thank you.